in metamorphic rocks today. Mountain sizes are high above the surrounding areas. Mountains have roofs and deep crust. Stress, pressure, strain. Those are some topics we're going to talk about. But first we're going to talk about compression. It's the push of the rock towards the center can slip into form. Some form new metamorphic structures. Tension is pulling apart. The pieces of rocks can also slip away and fracture and deposit minerals into the structure's pieces. Okay, shear is the sliding past of two rocks. Shallow part is sometimes the fault between the two rock masses. In deep, ductile environment, it is common in wide zones to see shear. And these are the zones of shearing is called shear zones. Volcanic island arcs are formed by the volcanic underwater. Syncline is old, young, old. The deepest of the depends on the type of rock. Should runs through spinal, syncline spinal. It's a U-shaped form of the mountains, and syncline is the N or rainbow-shaped one. Anti-syncline, sorry. It is the shaped as young, old, young is the age of the mountains. It's important to know. How can you tell what happened to the mountain? Look at the direction of the rock layers. You know, of any kind of rock really, not just mountains. Look at the rock layers, look at the older, it's usually on the bottom, and the newest ones are usually on the top, the younger ones. It's like the pages in the newspaper. It's like you can literally see the different times. Be careful of cross-cutting because those ones are usually younger in different areas that you would assume would be older. Orogenesis. These are the two types: are volcanic arc, island arc, and continental volcanic arc. And I like to remember this as VIA and CVA. Collisions of the two continental plates and the faulting blocks mountain are important. When does a collapse happen? Rocks move from the top to the bottom, where they to the base. The taller, the higher, the bigger the mountain, the younger. Stronger base is likely not so tall. Shorter mountains mostly means they're older mountains. Okay. The note says lots of these underwater mountains on Earth. We sometimes forget about these, but they're actually bigger than Mount Everest. Like there's one in Hawaii. Mapping the seafloor with probe was one of the first ways. Sonar, sound waves, was like during World War II. I think a British guy discovered it. Satellite screens to be preferred. Satellite is like the preferred way to do it nowadays. It's to look at its topography. There's only 5% of the ocean has actually been mapped. The ocean is a vast body of water with salt. Okay. Orogenesis is the mountain building. This is the creation of mountain ranges and depends on plate tectonics. Mountain gives records to weathering, landslides, glaciation, and erosion. Weathering degrades the mountain. Most mountains were about less than 100 million years old. How do we know what a mountain is? It's defined as the large land that rises vertically above the land around the area. Mountains are formed through tectonic forces or volcanic effects. Old mountains, we talked about a second ago, but here's a recap. Old mountains have been eroded and wet. And some of them glaciation, letting left marks. These were not the same as they were when they first started. They're very, very old, hundreds of millions of years old. Young mountains are about 45 million years old. The biggest, the older, bigger than older. Bigger than older. They're bigger than older mountains. And there's some of them are still getting much, much bigger. Isosity is isosity. Rocks grow deep within the mountains, go out horizontally, okay, side to side, horizontally, some point and seem to flow. It's got this structure. Back to Orogenesis. Again, we're doing another recap. There are many types. One of the first ones is volcanic island arcs. Volcanic island arcs are developed when an oceanic plate subducts under another oceanic plate tectonic. These result in either volcanic island arc, the simplest mountain belt, or the deep ocean trenches. The Mariana Trench is the deepest place on Earth. Ocean, there's a trench there that's deeper than Mount Everest. It's really cool. James Cameron went there. Okay, the continental volcanic arc developed when an oceanic plate is subducted beneath the continental plate. Okay, so the continental plate is subducted. No, the oceanic is subducted beneath the continent plate. Okay, this is the most violent one. It's called the continental volcano. And plutons. This is where crystallized magma deep inside their mantle. If there's magma, it's gotta be in the mantle because the crust is, it's just, the crust is rock. It's like right up, like the front of the mantle, the top. Himalayas are the youngest and the highest mountains formed from the continental collision on Earth, and still are forming from 40 to 45 million years old. They are formed when India was colliding with Asia. This happened because of the continental volcanic arc formation on the Asian continent. It collided the crust and it did not subduct. Instead, it went above and built this big mountain. The compressional forces help build many mountains. Compressional forces typically end in reverse or overthrust faulting. How do rocks bend? Four major factors that determine bending or breaking. The type of forces applied is the stress, the pressure, the temperature, the rock mineral composition. This is what the heck are we looking at? What kind of rock is this? Composition. Okay, my instructor says change the size and shape or position of the rock body is a response to stress. Size and shape are a result to stress. Okay, response to it, not just a result, response. Okay, stress is just an unequal direction force implied. Deformation is three types that are important: elastic, ductile, or plastic, brittle, or fractured. Elastic deformation is when the rock bounces back, like squeezing a pillow or rubber thing. Ductile causes permanent change, does not recover from this. You can't recover, it's like the worst thing. Strength refers to the ability of an object to prolong deformities. Strain occurs when the stress is unable to reverse the shape or size of the rock. Talked about this earlier, I think. It is the outcome of the stress. Stress process: 1. Elastic. 2. Plastic region, ductile, and then the final is fracture. This leads to the ability where it's brittle, it just breaks. It's like the coup de grace. Okay, the brittle rupture deformations when the rock undergoes almost no change until the assembly cracks. Applied on the zone of the weakness. Brittle and deformation forms, the fractures or joints, zones of fault lines, or brittle attributes to the sudden change. Reverse faulting. Normally faulting strike off faulting. So the way I remember reverse faulting is like high to low. No, excuse me. Low to high is reverse faulting. High to low is normal faulting, and then strike up is like sliding past one another. Brittle rocks are usually granite, quartzite. Ductile rocks are salt, shale, marble. These are some of the familiar ones. More ductile and It's deeper, more brittle, shallower depth. So it's like top layer. What is the reality? What is really in the different of stress and strains? Here's another last recap, just to let you remember. Force of rocks is given. It could be compression, tensional stress on the rock. Strain is the plastic, ductile, or brittle means that results in the shape and size of the rock structure due to the stress put on the rock. Okay. So then the earthquakes. Okay, this is going to be just facts. Earthquakes, release of energy, crustal lithosphere by faults. The Earth is 4.6 billion years old. In the 1600s, it was relative age dating. They discovered this. One of the minerals, it's called metal. It's always an ore, or the ores are always metal. Epicenters. This is part of earthquakes again. Is the point directly above the focus. It is the earthquake of an earthquake on the Earth's surface. Back to metamorphic rocks. The temperature is the most important factor out of all the metamorphic factors. Out of the three of them, three are temperature, pressure, fluids, and they're all controlled by the different temps, different pressures, different fluids inside. Temperature results in recrystallization and creates new minerals. How's the Earth warmer internally? Well, energy from the Earth is released by radioactive decay. Thermal energy leftovers from an Earth was just a baby. Or younger, I guess you could say. Formation of rocks is strongly influenced with the increase of temperature and pressure. And as higher pressures and temperatures, we get crystals. And these increases the temperatures and increases the pressure increase the depth. We get different minerals at different levels of depth and temperature too. So we can get new stuff, different temperatures and depths. And that pressure can change the mineralogy. Most metamorphic rocks are created regional metamorphosis. This means that segments were deformed along convergent boundaries. Convergent mountains, okay. There are different levels of stress along the wide range of the area. Though they can all be considered the same level of stress. There are two main types of pressure. There's confining pressure, all directions. Then there's differential pressure. There's just partial, direct pressure. Most metamorphic rocks have the same elemental pressure, elemental composite of elements. As majority from their parents' rocks, they are the same. About. A little bit different, but they're about the same.